Hey everybody, let's look at this problem, subtree of another tree. Given the root of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node value of subroot, which means if we have this root over here and we have this subroot over here, return true if this subroot is a subtree of root. As you can see, 412, 412, it is there. We are also given that a tree can be considered subtree of itself. So if we did not have these roots, the, the output would still be true. So to solve this problem, what we can do is we can take the root and we can traverse through this particular tree in every direction. Every time we encounter a node which has a value similar to subroot, the root, which means the value of the subroot, we would start the comparison, which means we go left on this tree, we go left on this tree, we go right on this tree. We make that comparison of the subtrees. So to solve this problem, what we can do is we can traverse through this tree in every direction. And every time we encounter a node that has a value similar to the value of subroot, we would start the comparison. This is going to be a basic tree comparison of this and this. And we would only do it if these values over here match. So we need two parts of this. One, in this problem, we need two parts. One is the tree comparison, and the other one to traverse through the root tree. So now let's take a look at the code implementation for this to understand this problem better. So I'm here in the code editor. I'm given this function is subtree. The two inputs are root and subroot. The first thing I need to check if the value at root and subroot is equal. If it is equal, I would check if those trees are equal or not. So let's check the root first. If root dot value equals to subroot dot value, if this is the case, let's check. So I would like to create a function called check, which would have root and subroot as their input. If this function, which I would write, if this function returns a true, I can say that I found that the subroot is part of root, means return true. If that is not the case, let's check in the left subtree and the right subtree. So self dot is subtree for the root dot left, since we are traversing the root, but we are not traversing the subroot. The subroot would remain as it is. Either I find in the left subtree or I find this in the right subtree. So right subtree, root dot right, subroot. And the answer from over here, whatever true or false, I can return back from its subtree function. Also, I need to take care of the base condition, which would be if root, if not root, which means I'm on the edge, I'm at the leaf node and the value of root is none, I can say return false, which means I never found anything, which would be a case with root as 5. I would never be able to find the subroot over here. So this part should return a false. Now let's write this function check. It has root and subroot as input. The first thing I would check if the values match. So if root dot value matches with subroot dot value, if the values match, I want to check further, which means return self dot check. Let's check on the left subtree root dot left and subroot dot left. Let's also check on the right subtree. Everything should match. So we would write end over here, send self dot check root dot right subroot dot right. If this does not happen, if root dot value does not match with subroot dot value, I can say that the two trees cannot be equal. So I can return from over here false. Also, I need to make sure that I am taking care of the base conditions. As you can see, we are not returning true from anywhere right now. So at what point can I say I'm done checking? When both the trees end, which means if not root and not subroot, which means both the trees ended, and I can say if both ended and never returned false, which means I should return true from here. If one of the tree ended, I can say if not root or not subroot, one of the tree ended, I can return false from here. This should be the code. Let's try to run it. Okay, so we have a typo here. Let's run it again. Let's submit it. So we have a solution.